Hi everyone, welcome back to my channel. So this video is going to be about recommendation systems and how recommendations work, particularly in the context of a popular food delivery platform called DoorDash. So personally, I use DoorDash a lot, and sometimes I'm quite intrigued by how apt their recommendations are. Like you usually get those recommendations at 4 o'clock, try something new. And DoorDash recently released a very beautiful blog 3 or 4 months ago about how what is the architecture behind their recommendation systems, how do they go about sending these notifications. So we'll use that as a resource and try to understand completely how does recommendations work in general as well as in the context of DoorDash. So as you can see in my screen, this is the blog that DoorDash had shared. So as evident, they're using graph neural networks for their recommendations, and they have provided a very nice explanation as to how this works. So as you see, right, I was talking about the notifications that you get. So here it says, try something new on DoorDash. Hi, Zidong, in the mood of something new. Try one of these spots you haven't heard, like Starbucks chicken and many more, right? So we'll try to understand how does this work. We'll first try to see how do traditional recommendation system works, then compare them with graph neural networks. How does their recommendation system work? And then sort of come to a conclusion, right? So let's get started. So yeah, how a traditional recommendation system works is, as you can see in this table that is given here. So suppose there's a user A who has rated the movie Matrix, and user A has also rated the movie Inception. And as you can see, user A and user B both have rated the movie Inception. So the algorithm is going to identify some similarity metrics between user A and user B because they both like the movie Inception. And now because these two users are mapped, since user A likes the movie Matrix, the system will recommend the Matrix to user B as well. So kind of that's how it works. Similarly, if the user A, as evident, it is into science fiction movies, it might recommend another science fiction movie to user A or user B, whatever. So as you see, like here, the kind of computation that we see is kind of static. You can imagine traditional recommendation systems being, flat tables where you can add these ratings and all you can specify these relationships in rows and columns, and that's how these recommendation system work. Now graph neural networks, what makes graphs so special? First, let's just try to understand what are graphs. So graphs are a way to represent information in the form of nodes and interaction. So here you can see, like, imagine Facebook, right? Facebook, like each of these circular things out here is called a node, and these dotted lines are called interactions. So Facebook, suppose you are user A and there's another user B. You two are the two nodes on the graph, and the thing connecting you is called an interaction, and that interaction could be your friends or your followers. Or user A could be connected to user C, and they can be connected to interaction in a way that user A and user C have similar music listening patterns. And this network can expand to infinite levels, right? So that's how graphs look. Now we'll try to represent all this information in a graph and see how it works. So as you see, as I told you, these circular things are called nodes, and these dotted lines are called your interaction or edges. So in the case of graphs, so as you see, user A has like the movie Matrix, but now in the case of graphs, you can have multiple information about the movie, like Matrix. It knows the graph neural network. You can map these relationships by adding more nodes to the graph. So this node, like, it's a sci-fi movie, it's an action movie, it has high visual effects, the plot is complex, it's a philosophical plot. So similarly, user B likes the movie Inception. It is going to get all the attributes of Inception in the form of nodes. So user B also Inception also shares these common characteristics, right? So now the after analyzing the user's genre preferences, director preferences, movie style similarities, the graph neural network is able to make a more nuanced recommendations, not just on the basis of ratings, as we saw earlier in the case of traditional systems. It's able to recommend Blade Runner on the basis of similar visual style, like use of VFX, complex plot, philosophical plot, as we saw here, right? So the granularity of information that a graph neural network has is way more than a traditional recommendation system, right? So the traditional systems don't understand why. That's the key point. Why does a user like a certain movie? Whereas graphs are able to understand the complete nuances that gets into the user liking a movie. So user A doesn't will not like the movie Blade Runner just because it has a matching with Inception. User A will like the movie Blade Runner because user A is into science fiction movies, user A is into action movies, user A is into movies with high visual effects, and so on. Right. So this is what the advantage we are getting out of graphs. So a traditional recommendation would look like, hey, so there's another movie which similar users have rated highly, like we saw in the first case. Whereas the graph neural network will say that here's a movie that matches your taste in style, that matches your taste in narrative complexity, and that possibly matches your taste in the time also when you watch the movie. So we can add one more node here that says that what time is this movie being watched, and it'll be able to understand that. Now, a question might arise in our minds that, okay, the graph neural network is able to give us a more personalized recommendations on the basis of access to all these features, right? But we can see that, okay, that's the case. What if I add three, four more columns to my traditional recommendation system as well, right? What's the difference here, right? So if I add in the traditional case, if I in the basis of row and columns, I add this rating, genre, and I can keep on adding thousands of features, right? But what distinguishes graphs is the way they compute these features. A traditional systems typically process these other features as independent. They can't possibly check what is the relation between interdependency between features. It's kind of a linear approach how traditional recommendation systems approach recommendation. Whereas suppose if in a traditional system, if you want to analyze what's the relationship between a genre and a director, is there a particular correlation? Does a particular genre by a director leads to more ratings? So the traditional system won't be able to understand that because it is limited to doing linear analysis. It's kind of it's quite similar to how traditional machine learning algorithms differ from deep learning. So let's just understand that. So in the case of a simple traditional machine learning algorithm like a regression, right? So suppose you're trying to predict house prices. So house prices, you can say square feet is one feature that can be used to predict the house price, and the number of bedrooms it can be one more feature to predict the house price. So the price can be your standard. Like you fit this to a graph y equal to mx plus c. So W1 into square feet plus W2 into bedrooms. But what about how these two features interact with each other? What about what will be the price when suppose if the square feet is something, how, and the bedrooms is some value? What will the interaction between two features? How will the interaction between two features affects the price? So that is something which traditional machine learning algorithms struggle to do. That obviously you can, as you can see here, you can manually create these features that square feet into bedrooms can be the third feature, and that's how you can calculate interdependence. But there's a lot of manual pressing. It's not generally just multiplication. You need to do a lot of manual processing, and you need to come up with a strong logic as to how can you measure the interdependence. Whereas in the case of deep learning algorithms, you just pass on these features to a neural network, and as you know, in a neural network there can be many hidden layers. So each of these features is processed in multiple hidden layers, and they are able to understand this interdependence between these features through the hidden layers. So let me just explain this in a brief figure that I have, which is, yeah. So as you see in this figure to your right, for linear regression like algorithms, you can see that there is no interaction between square feet and bedrooms. Whereas square feet is first passed to hidden layer 1, bedrooms is first passed to hidden layer 1. Weights are applied, activation function is applied to each hidden layer, and then a value is then we get a value. Similarly, there can be multiple hidden layers through each iteration, and we will be able to get what the prices are, right? So yeah, as we saw, like, so the deep learning network will be able to understand things like below 500 square feet price increases linearly. So below 500, and between 500 to 700 square feet per bedroom, prices increases faster. So you see the interdependence between two features. This is not something which traditional machine learning algorithms can do easily. You can argue that, okay, leave out regression. Decision trees can do that by, you split the trees, you provide these splitting on the trees. You can use GNN and all. But in that case also, you have to specify the rules. In the case of GNN, you have to use Euclidean distance and you have to specify the rules. Whereas in the case of deep learning algorithms, this sort of happens on the fly. The deep learning, the hidden layer calculations by the activation function is just happening automatically. You don't have to manually engineer and create these features, right? So as we saw, features contribute independently in the case of traditional, whereas feature interact through these hidden layers. So we kind of understand the relationship between features as well, like ratings, genres, directors. How do these features relate among each other? That is what gives us rise to a better recommendation system that graph neural networks can do. So now we'll try to understand how does a graph neural network do that, right? So we will just look at this figure that I have, not this one. So just a second. Let me just close this one and yeah. Let me have this. Oops. Yeah, so all set up now. So yeah, like in the beginning, how does a neural graph neural network understand these nuances? So what a graph neural network does to get understand relationships between features is that it uses something called message passing, where each node in the graph is able to pass its message to the subsequent nodes, and that's how it learns on the fly automatically, and it is able to discover paths and correlations that help it to understand the relationships between features in a more correct manner. So we'll try to understand what is happening here. So in the first node, you see, so what's happening here is we have user one, he likes the movie Matrix, and we have user two, he likes the movie John Wick. And now we'll understand how is the graph, how will the graph know what to recommend to user one on the basis of the information that we have. So in user one, you can see the features that we have is the age of user one is 25, and he's a sci-fi fan. And what we have is regarding Matrix, this is a genre and the year it was released. Keanu Reeves is the actor for the third node, and John Wick is another action movie. And year when it released was 2014. And we also have some attributes about user two, which is his age is 30, kind of similar to user one. And he's an action fan, whereas user one is a sci-fi fan. Now, each message is passed to the neighboring node. So the message from user one will be passed to the Matrix two. The message from Matrix will be passed to the Keanu node, and so on. So the information flows from user one to the Matrix. So what the Matrix receives from user one is user's age is 25, as we see on the left. The age of the user is 25. The user preference, he's into sci-fi movies, and he has rated the movie Matrix 5, and the interaction type is rated. Now, similarly, the information from the Matrix node goes to the Keanu node, where the message that Keanu receives is the movie genre of Matrix is sci-fi. The movie success, it has got high ratings, five stars, and the user demographic is young sci-fi fan, because this person is 25 and he's into sci-fi, right? Now the same thing flows into the John Wick node, where it understands that the actor experience is high because Keanu Reeves age is 57, and it is the movie that it was related before was Matrix, which was a sci-fi movie, and the audience type was young because he's 25 years old, right? Now, so the pattern that the graph neural network has learned is from user one. User one likes Matrix, which is a sci-fi movie, and it has rated it 5 stars, whereas user two likes John Wick, and it has also rated it 5 stars, right? So the user now through this message passing, the GNN is able to learn when a movie shares an actor with another movie, right? So John Wick and Matrix, the shared actor is Keanu Reeves. Even if the genres are different, as in the case of user two is into action movies, user one is into sci-fi movies, right? So even if the genres are different, users often enjoy both movies if the actor is successful in both genres. So because Keanu Reeves has been successful in both movies, Matrix and John Wick, the graph neural network is able to capture this relationship, and using mechanisms like the attention mechanism, it gives a higher weight to the same actor related genre patterns. Because it gives a higher weight to this pattern by the virtue of using algorithms like attention. This is the reason why the GNN can make an intuitive leap that user one who likes the Matrix might enjoy John Wick, even though they are different genres, right? Even though they are different genres, because they share the actor Keanu Reeves, as we saw through the message passing. Both movies appeal to the similar age demographics, as we saw. User two is age 30, user one is age 25, and there's a pattern of sci-fi fans enjoying action movies, right? Because as we saw here, the attention will give more priority on the basis of the message passing that user one and user one like the movie Matrix, and user two like the movie John Wick, right? So this is the power of message passing, is that the GNN is able to understand these patterns automatically. There's nothing much you have to do. Like you just first you kind of encode the features, right? The zeros to ones, like because machines can't understand numbers for things like if he likes a sci-fi movie, you have to convert it into one, because it's a vector, right? It's called vector embeddings, because as we learned in junior classes, vector is something that has both magnitude and direction. So sci-fi movies having one will be placed at will convey an opposite movie to a movie which is action, which is because it's not a sci-fi movie. So they'll be placed on opposite ends. So after getting those embeddings, you pass these messages to each node, then you aggregate the messages over each node, and then finally using a mechanism like attention, you will learn to prioritize which chains more. So for example, the network learns to give higher attention to important relationships. For example, the graph neural networks learns that the actor movie links matter more than the year movie links. So there can, so as you see, right, there's one more feature where when was the movie released, the year the movie was released. So that doesn't matter, and the attention by the virtue of this message passing and the can understand which linkages matter more. So, and this happens because during training, the attention mechanism learns to give higher weights to important parts, and it can discover that the actor genre is a very strong signal. So this is how a graphical neural network learns to provide recommendations by this automatic virtue, by its automatic virtue of using the message passing and things like the attention mechanism. So if you ask what happened in the case of traditional systems, well, in traditional system, you have to manually create these features. You have to manually engineer. You have to establish relationships, create defined functions. Whereas in the case of like you have to specify these rules in the case of traditional systems, where you have to, if actor is common and if the actors are common and the genre is similar, then only recommend the movie. It's kind of like similar how banks shifted from using rules-based fraud detection algorithms, where banks would have predefined rules. So if this user made an transaction at 3 a.m. in the morning, then he's fraud. Whereas now they're adapting to using machine learning algorithms when to detect these fraud cases, right? So it's kind of similar to that. So yeah, message passing allows the information to flow through the graph. Attention mechanisms learn which connections matter, as we saw, and the neural networks learns to combine these features from different nodes and predict and make a recommendation. As we saw here, the user one will be recommended the movie John Wick on the basis of the message passing and its similarity to user two, like as we can see. So yeah, this is what that was about how traditional versus graph neural network works. And now we'll try kind of sort of jump into the blog and to understand how GNNs are being used at DoorDash. So for this, I've developed a interactive visual sort of a thing using JavaScript for your understanding, right? So we'll try to see what's happening here is, so first, what does DoorDash will do for any customer here? It will first it'll first start building Sarah. There's a customer called Sarah, and she's on DoorDash, and she's interacting with DoorDash. She's leaving a digital footprint whenever she's on the app, right? And DoorDash collects all that information. And this you can see by in this section of the blog, they say that, like things like if a user has saved, this information is captured by DoorDash. If a user has ordered, this information is also captured by DoorDash. If he or she has rated, if he has even viewed the restaurant, all this information are used to conduct that graph neural network for DoorDash, right? So suppose in the case of Sarah, let's analyze Sarah, right? So Sarah has ordered from this Thai place. She has ordered thrice, so it's a strong connection. She has ordered from this Japanese place called Sushi Co twice, Asian Fusion Kitchen once, and Dragon Bowl. She has viewed. She hasn't ordered. She has viewed this restaurant called Dragon Bowl, which is a Chinese restaurant, and she has also viewed this restaurant called Noodle House, which is a Asian fusion restaurant, right? So now after it has gathered sort of all the data, now it'll start generating those embeddings and using the encoder of the graph neural network, and it'll start to build the connections. So the first connection is so Sarah likes the Thai place, and she's made 3 orders, so it's a strong connection because she's ordered thrice, right? And a medium connection for Sushi Co because she has ordered twice. A light connection because she's just viewed it, and very light because she's just viewed the restaurant, she hasn't ordered it. Sorry, and for Asian Fusion Kitchen, it's a light connection because she has just ordered it once, right? So now another connection could be the restaurant connection. So the neural network identifies that Thai place is an Asian fusion restaurant. So it can look for similar cuisines, price ranges. Sushi Co is also an Asian fusion kitchen. Dragon Bowl is a noodle house. So it'll start building up these connections, right? So now it'll try to map Sarah with similar users. So Mike has also ordered from the Thai and sushi places. Emma has also ordered from similar Asian cuisine places, right? So now, how are these recommendations generated? Now we come to the interesting part. How will these recommendations be generated, right? So scenario one, it'll try to make recommendations on the basis of similar restaurant patterns. So what's Sarah's pattern? So Sarah has ordered from Thai place thrice. It's a very strong connection, frequently ordered, right? So the graph neural network observes that similar users who like Thai place, it sees in its ever expanding network that similar users who like the Thai place also enjoy Bangkok kitchen. They also enjoy green curry house, and they are both Thai cuisine restaurants, right? So now you'll get a recommendation on if it's recommending on the basis of similar restaurant pattern, you will get a recommendation usually at 4 p.m. or depending on your order pattern when you usually order from DoorDash, you'll get that recommendation. So try something new, Bangkok kitchen, popular among Thai food lovers, right? So yeah, that's how it works. Now another recommendation could be on the basis of category extension. So where it analyzes the category first. So Sarah has multiple two orders from Asian restaurants. So the graph neural networks observes that users with similar Asian cuisine often enjoy Korean food. So in the vast neural network, it is seeing that people who have ordered from Asian restaurants are also a couple of users have ordered Korean food. So again, you'll get another notification on your phone that expand your taste, Korean barbecue house, popular among Asian cuisine lovers, right? Right. So you see how it is analyzing the granularity of all the features available to make such personalized recommendations. Another, like now there's a view-based recommendations, right? So as we saw, Sarah had viewed Dragon Bowl multiple times but never ordered, right? As we saw in the first ordering history, she never ordered. So the GNN will observe that users who view but don't order have a price sensitivity because they have viewed it and haven't ordered. So they notice that among users, among that vast network that they are continuing to build, they see that among users who have a price sensitivity, Lucky Walk Chinese restaurant is quite popular, right? And so it will recommend to Sarah, hey Sarah, a recommendation might come again at 2 or 3 o'clock whenever she orders her usual time, and you might like Lucky Walk, highly rated Chinese cuisine at great prices. So yeah, this is how it is analyzing through such a wide array of features to give such personalized recommendations. Now, like, let's look at how this happens in real time, right? So imagine Sarah is at her office, it's lunch hour, and she has turned on location features for the DoorDash app. So DoorDash is able to identify that it's a work location. So DoorDash knows that Sarah has ordered Thai twice a week already, in the previous week already. So the graph neural network, how it works is, in the case of DoorDash, they'll apply some geolocation filters to ensure that Sarah is getting the recommendation in her wherever delivery is available. So if Sarah is located in Calgary, she won't get a restaurant that is located in Vancouver. It has to be in the same geo hash filter. And this is something that DoorDash actually uses, which I'll show you. So it'll apply those features, like the restaurant should be within the delivery address, and it will filter out new restaurant that she hasn't tried. It'll get her price range from its vast analysis of the digital footprint that Sarah has left on DoorDash, and it'll get the list of all restaurants that are available for recovery. And on the basis of that, it'll generate a new recommendation. Hey, Sarah, try something new. Bento Box Express, popular among Thai food lovers in your area, right? So yeah, this is how it works. And the best part of it, of graph neural networks, is this continuous progressive iterative learning. Now, as we saw in the category extension part, where it recommended that because the graph neural network saw that people who are liking Thai food are also ordering Korean food, and Sarah went ahead with that recommendation and she ordered Korean food. It is going to add that information in the network. So that network is ever expanding every day. If you go by the recommendation, it adds that node and that connection to the network, which strengthens the graph neural networks, and it reinforces it to provide more correct recommendations. So the graph neural network updates and strengthen the connections to Korean restaurants, creates new potential recommendation, meaning other Korean restaurants can be recommended now. Korean fusion restaurants can be recommended now. Restaurants popular among other barbecue lovers can also be recommended. So you see the power of this. So every time a user is going by the recommendation, it is ever expanding, ever learning on feedback. So the thing continues to grow, and it helps us to make these personalized, nuanced recommendations. So the system continuously maps these new relationships based on orders, not only orders, the views. If you ordered from a restaurant, if you have viewed, if you have saved a restaurant, it continuously updates these connection strength based on the frequency of interaction. So every time you go on a DoorDash, you interact, it collects that information, and it analyzes what time of the day you're interacting with it, what time are you ordering, and it also sets up these location filters. So this creates a dynamic recommendation systems that gets more personalized over time. The beauty here is that it just doesn't look at direct relationships, not just what Sarah likes, but it also understands the broader context, similar users, restaurant similarities, viewing patterns, to make more nuanced recommendations that encourage exploration on the app while staying within Sarah's comfort zone of preferences. So yeah, this is how what I explained here. This is what is given in this blog. As we saw, the multiple components in the GNN include message passing. We learned what message passing is. It aggregates the information from each messages. The learning objective is set, which is to recommend each restaurant in a way that we saw, right? So and here they say that they don't send the notifications. They send notifications to the users once per day, and because as I said that we use geolocation to select restaurant candidates. So they put these geohash filters on the app so that your recommended restaurants only within deliverable areas, right? So yeah, this is the and they saw by implementing these recommendation systems, we saw a 1.8% increase in input metrics such as push and hub. So people actually went ahead with the notification they ordered, which possibly led to an increase in revenue. So yeah, this was it from this blog, and this was it that we could understand, like, how is DoorDash using graph neural networks, and the popularity of graph neural networks is increasing a lot these days, as I have seen from my research that I have done. Even DeepMind is also using graph neural networks in Google Maps to to provide accurate estimated time of arrival to certain places. So as you see, DeepMind partnered with Google Maps to improve the accuracy of the ETAs around the world. While Google Maps predictive ETAs have consistently been accurate for over 97% of the trips, we worked with the team to minimize the remaining inaccuracies further, sometimes more than 50%. Right? So, and they say to do this scale, we use generalized machine learning called graph neural networks that allow us this spatio-temporal reasoning, right? So they have used graph neural networks to increase their recommendation accuracy, to increase their ETA prediction level. Another one more thing I saw was even Pinterest. Pinterest is also they're developing this tool called PinSage. So we deploy pins. This is a research paper that you can read by Pinterest, which talks about how they developed PinSage. So they're saying that we deployed PinSage at Pinterest and trained it on 7.5 billion examples on a graph with 3 billion nodes representing pins and boards. So if you liked a particular pin on, say, about vintage chairs, right, it is going to provide you much more vintage chairs from Europe, or fine vintage chairs, like more nuanced recommendations. And as we saw, like graph neural networks are being used a lot like around us, and their popularity is picking up a lot of pace. And so I thought it'll be a good point to share what's the mechanism of how graph neural network works. And yeah, that's it for this video. I hope this video added some value to your learning, and you learned something from this. And I'll see you in the next one. Thank you. Bye bye.